Welcome to Rosmaya Mohtar YouTube channel. In this video, we are going to discuss on why are we unable to see clearly using glasses in water. Hi everyone, welcome to my YouTube channel. So what are we going to discuss for today? So in this video, we are going to discuss on Physics Semester 3 topic Geometrical Optic. Okay, refer to the video here. Okay, so this student is swimming in the sea. So can you swim with your glasses on? Okay, like this student. Okay, you will not be able to see clearly when you use glass in the water. Okay, and then why? Why are we unable to see clearly using the glasses in water? So wearing your glasses while swimming in the water isn't a good idea. Okay, this is another example. So the student here cannot see the wall made of glass here, and it hit. He hit the window glass, the glass wall here in the swimming pool. Okay, because he cannot see clearly. Okay, using the glass here. Okay, so if you want to go underwater for any length of time, prescription swimming goggles or a snorkel mask will help you correct your vision while underwater. Especially the swimmer here, very need. He needs a better goggles or a snorkel mask to help him swimming better. To clearly see in the water. Cool. So we will discuss this topic qualitatively using this example. So let's read first the example given. A student's spectacles consist of two concave meniscus lenses. So one of the lens has surfaces of radii of curvature 20.0 cm and 30 cm. So the refractive index of the material of the lens is 1.50. Calculate the focal length of the lens in air and then B in water. So given that refractive index of water is 1.33. Okay, so in the question you are given the radius, one of the side of the concave lens, okay, with the radius of curvature 20 centimeter. R1, another one is R2. So we are going to determine what is the sign for this radius of curvature, whether positive or negative. And then another given is refractive index of the material of the lens, okay, which is 1.50. And the focal length in air. So we are going to determine the focal length of the lens in air. So before the students go into the water, okay, with his spectacle, so we are going to determine the focal length of the lens of the spectacles of the students. Okay, so we do the first question first. And refractive index of water is given 1.33. Okay, so before you do this question, you must know the sign for R1 and R2 because the concave lens has two sides, the meniscus lens. So which type of the lens is? We have biconvex lens, plano-concave, meniscus, biconvex and plano-concave. So the lens, meniscus lenses here is this one. Okay, for meniscus lenses, the side which has a curved concave surface is negative for R1, and then positive it is if it is a convex surface. Okay, convex surface, positive R, and concave surface is negative R. Okay, so therefore the radius for 20 cm, which one is 20 cm? For the So how to determine the 20 cm? So the radius of 20 cm will form a smaller circle. So imagine this curve form a circle, okay, with radius 20 cm. So this is a smaller circle. Okay, so therefore is the sign for the R1 here is negative 20 cm. Okay, so the 20 cm here is negative. Okay, the sign, because this is a curve, imagine it form a circle here. So another circle, the outside, the other one, the other side of radius of the curvature will make a larger circle. Okay, you can imagine like this, it made a larger angle. So that's mean the radius of 30 cm, this will make a larger circle. So for this larger circle, the is a, if you face this side, you can see that it is a convex curve. Okay, convex curve. So therefore the sign for the R2 is positive. Okay, so we've done for the sign for the R1 and for the R2. Okay, negative 20 and positive 30. Okay, so here again, drawn again, okay, the circle made by the R1. We determine, we assume this is R1. The bigger one is R2. Okay, so this is how to determine the sign for R1 and R2. Which one for 20 cm or 30 cm is R1 and R2. Okay, so I repeat again, this side, the curve here is a concave surface, so negative, and for convex surface here is a positive sign. And to determine which one is 20 and which one is 30, so you draw the circle, complete the circle made by this curve. Okay, so if the circle is smaller, so it must have the smaller radius 20 cm. So for larger circle will give you must be made by the radius, larger radius 30 centimeter. Okay, next the formula we're going to use. Okay, next the formula. The formula we use Lenz-Maker equation here. 1 per f equals to n minus 1. Bracket 1 per R1 plus 1 per R2. Okay, so now we substitute the values, and the glass, the student spectacle is made of glass with refractive index 1.50. So R1 is 30, R2 is negative 20. Okay, then the answer is focal length of the lens in air is negative 120 centimeter. Okay, so we keep this value for a while to compare with the focal length of the same lens of the student's spectacles when he is in the water. Okay, so this is concave meniscus lens. So that's mean the value we should get here is negative. So the answer is correct because we get negative. Okay, so to draw the ray diagram, you can imagine it's like this. Okay, so the focal length here is 120 centimeter for concave meniscus lenses. Okay, next we calculate for water. So for focal length in the water. For focal length in the water, okay, we cannot use this because this one is in air. So we use the formula 1 per f equals to n2 per n1 minus 1 bracket 1 per r1 plus 1 per r2. So actually the above equation comes from this equation. Okay, we have derived this equation from the previous video, okay, from the previous lesson. So we just use this equation to determine the focal length of the lens, okay, in the water. Okay, now we substitute the values of N, okay, in water, N2 is lens, and 1 is the water, in the water, okay, and then the R1 30 and R2 negative 20. Okay, so the value, the answer is focal length in the water is negative 469 centimeter. So this is a very large value. So when the students wear his spectacle, uh, his spectacles, okay, in the water, so what happened to the focal length? So the focal length will change to a larger value. Okay, so you compare with the previous calculation in water. This is F in air. Okay, and negative 120. Then in water, it changed to negative 469. So this is the reason why we unable to see clearly using glasses in water. Okay, this is the main reason, because the focal length of our glasses has changed. Okay, so that's all for the video, and thank you for watching. See you in the next video.